In this video, we are going to discuss about the chemical reactions of amines. Chemical reactions of amines. The most important chemical reaction of amines is about their basicity. We will discuss about its basicity. Amines, they are basic in nature. The question is why they are basic in nature. They are basic in nature because this is the formula of amines. Because of the lone pair which is present on the nitrogen makes these amines as basic. Okay, what happens that these amines have this nitrogen lone pair for the attack of the electrophiles. Okay, and any compound generally in the exam a number of questions from acidity and basicity are asked wherever electron density is high. Okay, basicity is always high. Okay, higher the electron density, higher is the basicity, and higher is the electron density means that lower is the acidity. Okay, electron density is inversely proportional to acidity. Higher the electron density and lower is the basicity, and higher the electron density, higher is the basicity. So wherever higher the electron density will be there, more lone pair will be present, that compound will be more basic. And here amines are basic because of the lone pair of nitrogen. Okay, and wherever this electron density that is not very high, where electron density is not very high, electron density is less, their acidity will be higher. Okay, this is based on the concept because the bases, what are bases which accepts H positive ion, right? So this lone pair or the electron density, it helps the bases to accept that proton, while acids are those which leave their H positive easily. Okay, if electron density will be higher, the H positive will not be able to released. Okay, so that is why this is the concept of acidity and basicity. Now we will discuss specifically about amines. In case of amines, if we discuss RNH2, when it is added into water, it will dissociate into this. RNH2 is positive, this cation will be formed, right? As I discussed that these amines, these bases, they accept H positive ion. So one hydrogen ion from this H, it will attack over the nitrogen and result in the formation of RNH3 positive. Okay, if I write their base dissociation constant. Okay, what is the base dissociation constant in this case? It will be written as like this: RNH3 positive, and of these products it is written on the above side, and in the denominator it is written RNH2 and water. Okay, this is the base dissociation constant in case of amines. Okay, now whenever we have to represent the basicity, it is represented as pKb is equal to negative log Kb. It is represented in the form of pKb. So if pKb value is higher, okay, then basicity will be less and weaker is the base. Why? Because in this negative log is used. Okay, because of negative log, the values they will be reversed. So if pKb value that is high, then basicity, sorry, if pKb value is low, then basicity it will be higher. Okay, and stronger is the base. So this pKb value, it is denoted by pKb equal to negative log Kb. Okay, now in this, how the question is asked, we have to compare three compounds. Firstly, basicity in amines is seen in this order. That is, alkyl amines, they are the most basic, then ammonia, and then aryl amines. Okay, alkyl amines, ammonia, and aryl amines. Okay, what is the reason now? Firstly, we will compare between alkyl amines and ammonia. alkylamines and ammonia. We will compare between them firstly. For example, if we take example that is CH3NH2 is there, okay, alkylamine, which is more basic than ammonia. Why? Because in the CH3 group is present, methyl group is there. Now we know that methyl group has plus I inductive effect. Okay, it has plus I effect, which is electron donating in nature. Means CH3, it is pushing its electron towards nitrogen, increasing the electron density. Okay, by which electron density will increase because CH3 has plus I effect, which is pushing its electron towards the nitrogen. So that is why it is more basic, because of plus I effect of methyl group. In this case, there is only hydrogen. Hydrogen is not having any plus I effect. So that's why alkylamines are more basic. Okay. Now we will compare that why ammonia is more basic than aryl amines. What is the case? Again, we will stick to the basic concept which I have told you about the electron density, that we have to check where electron density is higher. Where electron density will be higher, their basicity will be higher. Now, in ammonia, the lone pair, it is present like this. But in aryl amines, what is the case? NH2. In aryl amines, this lone pair and this bond pair and this single bond is there, right? So these are in conjugation. So here, what will happen? Resonance will happen. Okay, lone pair, single bond, and double bond are present. They are in conjugation. So now, what will happen? It will come over here. It will go here. Then resonance will happen. Due to resonance, electron density will decrease because the lone pair, it is busy in the resonance, but it is not available for the attack of proton. Okay, now because in this resonance is happening and that lone pair is involved in the resonance and is not present for the attack of proton, that's why it is less basic. Okay, so this is the basic basicity order which you have to remember. With explanation you have to give, and this pkb value we have understood that how mathematically it is understood, and what exactly is basicity we have discussed that.